This is the third CODAP video. Hopefully I won't need to make any more. Once again, I just have my sample CSV here. If you need a reminder on how to upload files, go back and watch video 1. If you need a reminder on how to take pictures of your graphs once you've made graphs, see video 2. This video is to make scatter plots with multiple quantitative variables, and then look at linear regression and correlation between them. So once again, it's just a graph. One of the big mistakes students like to make when they're making their first graphs is they try to add a second variable, but we don't need a second variable for frequency graphs. We only need them if we're looking for the relationship between two variables. So you will want to make sure that you have two variables that are actually related. I think a lot of these ones are, but if we are looking for linear relationships and we find that two variables are not related, sure, you can run a linear regression on it, but if it's not a good model, then there's kind of no point. So we want to make sure that our R value is like 0.7 or above. CODAP will only give us an R squared value, which means you will have to do the additional step of finding R. It's just literally the square root of the R squared value. If you have a negative slope, you'll take the negative square root. If you have a positive slope, you'll take the positive square root. Remember, the sign of your R value, your correlation coefficient, just tells you the direction of the relationship. Negative means negative slope. The variables are inversely related. Positive R means positive slope. The variables are positively related. So if we think max height and drop are related, we could make one of them our x-axis, one of them our y-axis. So then drop. If you think that one of them is going to be the explanatory, one of them is then the response variable. So for me, I thought the height then is more likely to affect the drop. You could theoretically invert the relationship if you thought, well, I want to look at drop, and I think that those drops then mean they had to have had a higher max height. I would potentially buy that. To me, this seems like the relationship we're looking for. And this seems like a pretty strong relationship. So again, it looks linear. It looks like as the height goes up, the max drop of the roller coaster is also going up. So what we want to do is add a least squares line. So you can you don't need the count, we don't need the connecting lines, but we want the least squares line. So this is going to give us our linear regression, and it will not define new variables. It will use the name of the variable to represent that variable. So instead of giving you an equation in y equals mx plus b form, what it does is it gives you a drop, which is going to represent our y, equals m, that's still our slope. Our x variable will be the max height, and then our b value, our y-intercept, looks like is, in this case, is negative 0.25 feet. So everything is very explicitly written out, that the drop is related to the max height by 0.928 feet per feet. So for every additional foot of max height, the maximum drop of the roller coaster is increasing by just under a foot. So you increase the max height of a roller coaster, we would predict that the maximum drop of the roller coaster is increasing by 0.928 feet. And then our y-intercept is negative 0.25, which is telling me that it's not a realistic thing, but in the way that we would interpret it is that if our max height were 0, so if the roller coaster were completely on the ground, then we would expect to have a drop of negative 0.25 feet. And it's not realistic, but that's just what the model predicts. This is kind of an example of extrapolation. None of our roller coasters have a height below 18. So anything below 18 is now beyond the scope of our data, and the model is not going to be as accurate. We can also see our R squared value right here. So this is 0.893. If I wanted the original correlation coefficient, I'm just going to take the square root of 0.893. I'm doing this on my just a calculator here. I want to make sure that I then interpret it as the positive square root because I can see that this slope is positive. And I get a value of 0.945 essentially. So this is a very strong positive relationship between the maximum height of a roller coaster and its drop. So there's the equation. You'll want to make sure that we have the equation. We've got the line of best fit. I don't think there's anything else. If you wanted to look at the square of residuals, it's kind of a nice little visual of how much error you have between your actual data points and the prediction on the model. But it's really the only thing we need is that least squares line. So just as an example, let's see if I can find a weaker. So here is an example. The max height and the duration of a roller coaster. Maybe there's a little bit of an association, but we got some real big outliers over here that kind of mess up that pattern. When I add the least squares line here, again, it gives us a model. It gives us a line, this line here. But if we are trying to predict the relationship between max height and duration, there is so much variability here that it's not going to be a very good model, right? I could use this equation, but this is telling me, hey, the relationship really isn't strong. You shouldn't have a lot of confidence in your predictions. The R value, if I take the square root of 0.214, is like 0.46. So really, it's not a very strong relationship. If you turn in a graph like this, you're not going to lose points, but you're not going to get full points because this is not a strong linear relationship. And we want to make sure that we're looking at two variables that actually have a strong linear relationship between them. I believe that's everything that I have to show you for all of your assignments. This will be for your lesson 2 homeworks, as well as potentially your investigations, unless you choose to use another software like Excel. And as always, let me know if you have questions. The interface is very user-friendly, but only if you kind of know where everything is. So I hope that these videos helped a little bit. You can watch them again as you need to. And I might have to re-record them when students start pointing out different things that I didn't go over. So if there's something I didn't go over, please let me know so I can re-record these videos or make a 4th video of random things that I forgot. Thanks so much.